You can see a predicate logic on your screen, which contains no quantifiers. One can say this is a quantifier-free formula. I want to show you that you can apply the same laws from propositional logic in this case in order to translate this predicate logic formula, this first-order logic formula, to CNF. Okay, so I hope you remember the order in which the laws of propositional logic we are supposed to apply. First of all, we need to eliminate the implications from the formula. I think, first of all, I'm going to eliminate the implication in the middle, the main implication. So as you know, in this case, I have to negate the left-hand side of that implication. Then I'm using this junction, and I keep the right-hand side of the implication. Meanwhile, I would like to eliminate this other implication as well, which is great because I can also eliminate the negation here. Then I'm using a conjunction there, and I keep the right-hand side as it is. Immediately, I can eliminate this pair of parentheses. Okay, and now I would also like to eliminate the last implication on the left, which is a negated implication. Therefore, I can use the law of contraposition, which eliminates, this implication, then replaces the implication with conjunction and negates the right-hand side of the implication. Okay, I can also eliminate this pair of parentheses because I have a bunch of disjunctions in a row. Great. If you look at this formula, it's not in CNF, it's in DNF actually. And you probably remember what can we do in such a situation. We can apply the laws of distributivity. In this case, I'm going to apply the laws of distributivity to this operand, and I will connect it with the rest of the formula, and similarly I will connect this part and connect it with the rest of the formula. So at the end, I'm going to get px or the rest of the formula, qyx or px or qxc, and I take not qxc or and the rest of the formula, so I'm going to copy it. Okay, now let's look at this formula. First of all, to the left-hand side of the conjunction, you can see that px appears 2 times. Of course, we can eliminate the duplication like that. Now, this is a simple simplification. And also, if we look at the right-hand side of the conjunction, you can see q of x and c 2 times, but first time it's negated. So we have the same literal negated and not negated inside this junction. You probably know that this means that they are one together, which makes the entire formula inside the parentheses 1, which makes us able to eliminate this entire right-hand side of the conjunction. So after that, we can just erase this part and keep this part. So the final result, the most, the simplest CNF for this formula looks like px or qyx or qxc.